Alright, so this is part 2 of the solution video for exam 4. And next question is going to be a Thevenin question. Nope, it is an op-amp question. So we have a summer amplifier that was sketched in this problem. So we have R1, R2, and R3. B1, B2, and B3, and all that's going into the inverting terminal. Non-inverting terminal is grounded, and then we have an output V out and a feedback resistor. And I'll just go ahead and write in that the feedback resistor was 1000 ohms, R1 was 100, and R2 was 25. And what we're asked is to find R3 if V out is minus 10 V1, minus 40 V2, minus 20 V3. So R3 is here. R3 is here. So this minus 10 is the ratio of minus the feedback resistor over the input resistor. The minus 40 is minus the feedback resistor over the input resistor R2, and the minus 20 is minus the feedback resistor over R3. So if you do that calculation, minus 1000 over R3 has to be minus 20, and you come up with R3 is 50 ohms. Okay, so also a pretty straightforward problem, especially since you had looked at that circuit considerable amount. Okay, now let's look at problem 6. Problem 6 is a Thevenin, no, it is an inverting amplifier problem. So you're told an inverting amplifier has a gain of 10 and a feedback resistor equal to 100. Okay, once again, a super easy problem. Your inverting amplifier circuit looks like this. Here's your input. Here's your feedback. Here's V out. Here's V in. And V out is minus R feedback over R input times V in. And so V out over V in, which is the gain or the ratio of how much the voltage is amplified, is minus R feedback over R input, and we're told we want that to be 10, and we're told that R feedback was 100. Okay, so let me say one thing. When you talk about gain, you're ignoring the negative sign, okay, because you're just looking for by how much is the voltage magnified. So that means that our input, if our feedback is 100, our input would have to be 10. Okay, and now let's look at question 7. Question 7 is a max power problem. A very simple one, because I believe all you're asked to find is the resistor that will dissipate max power. Ohms, 30 volts, 6 ohms, 12 ohms, 8 ohm, and this is our resistor R. So what we know from the max power transfer theorem is that R for max power is going to equal R Thevenin as seen from the terminals that connect to this resistor. So what we need to do to find this resistor value here is we need to find the Thevenin resistance of the rest of the circuit. Now, as you know, when you have a voltage source, then when you're trying to find a Thevenin resistance and you have only independent sources, you kill those by short-circuiting the voltage sources and open-circuiting current sources. So what that does is we just replace that 30-volt source, so this is for R Thevenin. And replace that 30-volt source with a short, leave everything else just the same, and so what we want is R Thevenin looking right in here. So I have 4 in parallel with 6, which is 24 over 10, or 2.4. And I have 12 in parallel with 8, which is 96 over 20. That doesn't seem right. 12 times 8 is 96. 12 plus 8 is 20. Okay, do that, and you're gonna get 4.8. So now I have 4.8 ohms in series. Once I do the replacement here and here, those two become in series. So I just add those together and I get 7.2 ohms, and that's R Thevenin. But since R for max power is equal to R Thevenin, then it's 7.2 ohms. That's your answer. Okay, and I think that completes the exam. So you now have solutions to the exam so that you can compare